Hello world. Today we are going to see about the anomaly in the Earth's magnetic field. What, why, where, what are the problems that are going to be caused due to this? These are the questions that raise in your mind. Now we are here to give you all the answers. So subscribe our channel and make sure you like the video now. Earth's magnetic field is also known as the geomagnetic field. Is the magnetic field that extends from the Earth's interior out into space, where it interacts with solar wind, a stream of charged particles emanating from the sun. Fine, our topic is not about the magnetic field of Earth. It's about the anomaly in the Earth's magnetic field. The topic that we are going to discuss now is SAA, the South Atlantic Anomaly. It is an area where the Earth's inner Van Allen radiation belt comes closest to the Earth's surface, dipping down to an altitude of 200 kilometers. This leads to an increased flux of energetic particles in this region and exposes orbiting satellites to higher than usual levels of radiation. The South Atlantic Anomaly is a wide area ranging on Earth from southwest Africa to the regions of South America that acts like a dent in the magnetic field of the planet Earth. The charged particles trapped in Earth's magnetic field dip closer to the surface than normal, and their radiation adversely affects the working of satellites passing by the region and computers. According to the NASA, if a satellite is hit by a high energy proton, it can short circuit and cause an event called single event upset (SEU). This means that a satellite can suffer a momentary glitch or permanent damage. Hence, scientists shut down certain components or instruments while passing through this area. Actually, this effect is caused by a non-concentricity of the Earth and its magnetic dipole. The South Atlantic Anomaly is the near-Earth region where the Earth's magnetic field is weaker relative to an idealized Earth-centered dipole field. Coming to its position and shape, this is a cross-sectional view of the Van Allen radiation belts, noting the point where the South Atlantic Anomaly occurs. The Van Allen radiation belts are symmetrical about the Earth's magnetic axis, which is tilted with respect to the Earth's rotational axis by an angle of 11 degrees approximately. The intersection between the magnetic and rotation axis of the Earth is located not at the Earth's center but some 450 to 500 kilometers away. Because of this asymmetry, the inner Van Allen belt is closest to the Earth's surface, over the South Atlantic Ocean, where it dips down to 200 kilometers in altitude. This is the intensity of the magnetic field in the center of SAA from 1840 to 2020. This is the area of SAA from 1840 to 2020. The area is increasing gradually. The shape of South Atlantic Anomaly changes over time. Since its initial discovery in 1958, the southern limits of the SAA have remained roughly constant, while a long-term expansion has been measured to the northwest, the north, the northeast, and the east. Additionally, the shape and particle density varies on diurnal basis, with greatest particle density corresponding roughly to local noon. At an altitude of 500 kilometers, SAA spans from minus 50 degrees to 0 degree graphic latitude and from minus 90 degree to plus 40 degrees longitude. The highest intensity portion of South Atlantic anomaly drifts to the west at speed of about 0.3 degree per year. As the geomagnetic field continues to weaken, the inner Van Allen belt gets closer to the Earth with a commensurate enlargement of the SAA at given altitudes. Effects due to this anomaly in the Earth's magnetic field. The South Atlantic anomaly is of great significance to astronomical satellites and other spacecraft that orbit the Earth at several hundred kilometers altitude. These orbits take satellites through the anomaly periodically, exposing them to several minutes of strong radiation caused by the trapped protons in the inner Van Allen belt. The International Space Station, orbiting with an inclination of 51.6 degree, requires extra shielding to deal with this problem. The Hubble Space Telescope doesn't take observations while passing through the SAA. Passing through the anomaly caused false alarms on Skylab Apollo telescope mounts solar flare sensor. Astronauts are also affected by this region, which is said to be the cause of peculiar shooting stars seen in the visual field of astronauts, an effect termed cosmic ray visual phenomena. Passing through this area is thought to be the reason for the failures of Global Star Network's satellites in 2007. NASA has reported that modern laptops have crashed when space shuttle flights passed through the anomaly. The Pamela experiment, while passing through the anomaly, detected position levels that were orders of magnitude higher than expected. This suggests the Van Allen belt confined antiparticles produced by the interaction of the Earth's upper atmosphere with cosmic rays. In October 2012, the SpaceX CRS-1 Dragon spacecraft attached to the International Space Station experienced a transient problem as it passed through the anomaly. This is about the South Atlantic anomaly. Now, how this anomaly in the Earth's magnetic field is going to affect the mankind or human life, and little more interesting facts about this topic will be revealed in